Okay, hello to Reese and Josie and Carter and Eli. Okay, we are doing stats formulas for 7-1, 7-2, 7-3. We're going to hopefully get this paper filled out today. And then tomorrow we're doing Skittles on a Friday, right? That'll be Good Friday. But I want two, rows for 7-1. I want 2 rows for 7-2. I think I have this mapped out the way that I want it. And 1 row for 7-3. Because I'm not going to have you do the end thing for 7-3. Okay. And I will put on here confidence interval for proportion. This one is going to be confidence interval for mean. And this one is going to be a confidence interval for standard deviation. Okay?
It's only one box for, only one row for 17?
Yep. Because these ones down here are going to be finding sample size, which is n, and finding sample size. Because how do you find a sample size when they give you the standard deviation stuff?
Great question.
Use the table. Remember that? There's no formula for it. It's using the table. For standard deviation, you betcha. All right. I need some inspo here. What proportion do we want to talk about? What do we want to talk about? The proportion of what? People who use iPhones, iPhone versus Android? Yeah. Well, I guess it would be iPhone versus other because, there's some people who are not Android or iPhone users. Some people don't even have a cell phone.
What
I
is
don't know.
the sample for what? The second one.
What?
What is finding sample for?
Size.
Finding sample size.
Oh,
They're both sample size. Finding sample size, finding sample size. You get that far, and then we will zoom in. I got a paper cut just now. The worst place to get a paper cut is on the bend of your finger, either on the inside bend or the outside bend, because it's just whatever. It's inside's worse. That's where mine's at right now. You're getting a paper cut period is worse than stitches or anything else. Yeah, awful. Oh. Yep. All right, are we ready? Okay, I'm going to go to formula and then we'll go back to important information. So formula that you need is we are trying to find where P lives, and we have to have 2 numbers that he lives between.
are you on the first one?
Yep, I'm on the first one. First row, we're trying to find where P lives. And in order to find where P lives, we take P hat and we subtract the error, and we take P hat and we add the error. And that gives me my 2 numbers that P lives between. And to find the error, we take Z times the square root of, and this is going to be a big square root, P hat times Q hat over N.
Hold on.
La, 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 la.
Nice. How's Carter doing?
Okay, so ultimately we're trying to find this guy. Boop, boop, boop. Right here. Okay. All right. Important info. Which chart do we use?
What? Not the sheet.
What?
Not sheet. Z.
The Z chart.
Not sheet.
The Z chart, which is the bottom corner. The corner chart. Okay? We always use the Z chart for a proportion when we're doing with P's, okay? So that's the Z chart. That's important information. Should we write down what P hat and P and E and all the things are?
Yeah, probably.
Like Z is the number from the chart. Duh. P hat
Is that like the success rate?
is like your success, your proportion for success. Q hat, the proportion for failure. And it doesn't necessarily mean success and failure. It's just like what I want and what I don't, right? And the only other thing is N.
Number.
Number in the sample.
What is it?
The number in your sample or sample size. All right. Okay. Do we think iPhone? I don't know. iPhone, is that more than 50%, less than 50%? More than 50% use iPhone? Okay. All right. 65 out of 100 people use iPhone. Find. We'll go the 95% confidence interval for proportion of all people who iPhone. Who are my iPhoners and who are my non-iPhoners? We're finding a 95% confidence interval. They told me where you were.
Had to do a costume.
You had to do a quick run home.
Yeah, costume change.
Costume change, okay. Does any of that make sense? If you need to put more words in there, I really summarize, but if you need to put more words in there, you go for it. Okay?
Ooh, Kate, that smells good. Yellow sheet is
It's in
where?
there.
Oh, I'm sorry. You don't have one. I'll give you one.
Did you say take?
I got it from the gas station.
Just start where we're at and I'll bump back, Jose.
Okay. Sounds good.
Okay?
The world?
All right.
Hold on, Miss Ma'am.
Hold on, Miss Ma'am.
I can't write that. Oh, actually, I'm gonna be busy for a few minutes.
No.
Your dad has a nice mustache.
Thanks.
You can tell my friends do.
I think it's
I
from
know
TJ
sometimes
Maxx.
people don't get
It's
compliments.
either from TJ Maxx or Reese's. It doesn't have a Reese's
My dad,
logo.
hitting at his.
So I take it it's from TJ Maxx.
All right, ready?
Unfortunately, stuck with that one.
No?
Okay. You can catch up. We'll be all right. Okay? All right, we need P hat. We need Q hat. We need N. And we need Z. Why did I put N hat? I have no idea. N doesn't get a hat.
What?
No, N doesn't get a hat. P hat, Q hat, N, and Z.
But N feels left out.
I'm sorry. N doesn't get a hat. He's bald. Sure. Then you'll be looking at this. Then you'll be looking at this paper, and you'll be like,
I'm
"What?
putting a hat on.
What happened? Did he pin him?
And my
Yeah.
That was fast. Good job, Carter. You just pinned your person. Okay. Anyway, what is N in this problem?
We don't know.
Yes, we do.
100.
100.
65.
100. 65 out of 100. What does a 65 do?
0.6.
Yeah, so this is like 65 over 100, which is 0.65. Okay, that means Q is the non-iPhone users, which is 0.35.
Yep.
Yeah? And Z. We want Z for 95%, and if you look up on the Z chart, 95% is, you have these memorized?
1.645.
1.96. I'm pretty sure. Somebody check that.
Yeah, it is.
Okay. 1.645 is 90.
Ethan, you're wrong.
I need a Kleenex. I'm dripping. That's disgusting. You don't need to know that. All right.
I was just kidding.
Okay. Okay. All right. Here we go. All right. Now that we have our information marked, what do we need now?
Solution.
Yes. Well, what do we find now?
We need to plug it in.
We need to plug it in where?
Our equation.
The error. Okay. Z is 1.96.
Are we not using the other solution box? Or
Do we put this in?
Yeah. Let's put this in the solution box. We have enough room. We don't need to put anything else in there, right? Okay. 1.96. I'm just putting it close to that because then I don't have to zoom in and out. All right. 1.96 times
0.65
0.65
times 0.3
times 0.35.
over 100.
I'll just do parentheses. Over 100. Okay? If I were you, I would get a calculator out and make sure you type this in correctly and you get the same thing that we get so that you know how to type this in when you take a test.
It'll be fine.
Okay? Now, we are dealing with proportions, so I'm going to guess that this is going to be like 0.05 or something. I don't know. Okay? So, like, it's going to be like a small number because we're dealing with a proportion, which is a percent, which is less than 1. Somebody have this for me? That sounds awesome. 0.0934? What? 0.0935? Does anybody else concur?
Yep.
You did not do it.
I believe Matthew.
I believe Matt.
Even though his calculator is stupid.
I believe him too, but it's going to be really sad if we get to the end and it's not right. So I'm going to go ahead and do it.
If that happens, you can.
0.0935. Matthew's got it. He is doing awesome. I made the comment this morning. I was grading papers. I did. I made the comment to Ellie. I was like, Matthew is doing really well in this. I think you got like 7.1, 7.2, 7.3. All of them were 100%, and your explanations were really great. I made that comment to Ellie. I was like, Matthew's doing really well. There you go. Good job, Matthew. All right. So I know he should have been a stats major, right? So we're trying to find where P lives, and P. What do we add and subtract the 0.0935 from?
From our 65.
From our 65. So 0.65 minus 0.0935. That's a 9% like error.
5565. Well, no, wait. I didn't subtract them.
If you add them, it is 0.7435. So 74.35%. Okay? And I'm giving you both options here. If you subtract, what do you get? I'm sorry.
0.5565.
0.5565. Okay? So 55.65%, right? We're adding and subtracting this from P. All right? One of those two. I don't care how you write it. I will take either one. All right? Because you can have it as a decimal or a percent. I don't really care.
Thank you.
Or a fraction, but that would be even more
That would be
disgusting. So
ugly.
anyway, okay, all right. We're not going to use this box. I'm going to use this box for this up above here, but we're going to put an explanation in there. Can we do that? Because this box is not going to take that long. So we're going to put all this information in that box, but we're going to use this box for that box. Got it? That was a lot of stuff.
I don't know.
So this is going to be the explanation for that. This part, finding the sample size, we only need 3 boxes for. We don't need that much space. So I'm going to utilize our spacage, and this box is going to be the explanation. So
Okay, 1 second.
we are, okay,
Okay.
we are, how confident?
95.
95% confident that if we, 95% confident that if we do what?
Survey all iPhone users.
That if we survey all people,
Yeah. That many will be
all people, that's important.
iPhone users.
People,
I just do
that,
keeps.
sure.
PL.
If we survey all people that between 55.65% and 74.35% will what?
Have iPhone.
Be iPhoners. You can make that sound better.
iPhone users.
Sure. That requires more letters than what I just said. So the 4 parts to that were, how confident are you? You make sure you include the word all because we want to talk about the sample because that's what P is. P is a sample. We want our region in there and then we want what we're talking about. Okay, so those 4 pieces need to be there. And maybe you word it differently, that's fine. But all 4 of those parts need to be there. If you're missing one of the parts, I take off a point. Like a point.
Zoom out and go back.
Okay? There is that.
So that's part of the top.
That's part of that's this explanation. Explanation for that. Okay? Because we don't need that much space for the next one. I think I'm gonna skip down to the 3rd row actually. And then we'll do both sample sizes together. Okay? Like we'll do this at the same time we do this one, right? So that we're all in the same like brave wave here. Okay? Tate, we need a mean. Mean of what? You're my example comer upper with
Oh.
With her.
I need a mean of something.
Like what?
The average number of whatever is whatever.
The average number of cats with 4 legs.
My cat has 3 legs.
See?
No, that would be a better proportion though. The proportion of cats with 4 legs is like 98% or whatever. I need a mean. The average score on a what? Or the average height, or the average shoe size, or the average what?
Score on a chem test
Is a 70.
I felt pretty good about it today.
Do we want to do that? Average score on a chem test?
Sure.
Okay.
wouldn't feel so
All right. So here we go. Go down to the third box. I'm really going to mess you up here. Go down to the third box. I'm going to go to the formula, and then we'll go back to important info. So we are trying to find mu, because that is the mean stuff, right?
Wait, can you zoom out? How many boxes down?
How many boxes down? 3. The third box down. We're on the third
Do
row.
we need the solution box for the second?
No, because that went with this guy.
Okay,
Yep.
so confidence.
Yep. So mu for formula. How do we find mu? Where he lives between. How do we find these two numbers?
Okay, you can zoom back in.
X bar minus the error, and X bar plus the error. Kind of like p hat. Instead of p hat, it's X bar. Okay? And to calculate error, he is
The same formula.
kind of a little bit.
Henry, can I have a ride?
Okay?
set?
He is, I'm going to say Z or T times S over the square root of N. There's only like 3 little parts to it. Okay?
That's like
You use either the Z chart or the T chart.
Times S over what? The square root of n.
S over the square root of N. Okay?
It's less than 30.
Yeah. So we got to put over here. When to use the Z chart and when to use the T chart. Z chart. Okay? Now, I know that there has something to do with if we know the population, standard deviation, whatever. I'm not going to give anything to that to you.
Can I do
Okay?
number 30?
T chart. Okay, I'm not going to worry about whether we know the population standard deviation. I'm not going to give you any of those. I'm going to say that if n is greater than 30 and if n is less than or equal to 30, we're going to use the T chart, we're going to use the Z chart. Okay? So you got to make sure you're using the right chart when you're doing a mean.
What
Okay.
if it's... Oh, never mind.
If you use the wrong chart, then you miss a point. Like when you guys take this test, I go through this test with a fine-tooth comb. And you're glad that I do that because if I just look at the answer and the only thing you did was use Z instead of T, your whole equation is going to be wrong and the very wrong answer, at the end. And I'm not going to take off the whole point for that. Like you're not going to miss the whole problem for that. You're going to miss 1 percentage point. So it knocks you from 100 down to a 99 because you used Z instead of T. If you did everything else correctly, right? Like that's how I do that. So I really fine-tooth comb all of your tests and stuff from here on out because there are so many moving parts to it. Got it? Okay, we need to know okay, so we need to know Z or T. Okay, and it is the number from the chart.
Thank you, Tiffany.
Okay, we need to know what S is and we need to know what N is. N is the number in the sample and S is the,
Hold on. Sample size.
no,
Standard deviation.
standard deviation. It is the sample standard deviation. That's what S is. And that's all. And what were we doing? Oh, average on a chem test.
I feel as though it should be 80.
You feel as though it should be 80?
I feel like none of us have gotten 70s yet.
20.
I don't know other people's.
2
grades, but-
students had a mean chem score of how much? What are we saying?
70.
70? Okay, sure. 70 with a standard deviation
5.
of 5?
15. 10.
Let's say 15. Because you have some people that get up there, but then some people that get really low too. With a standard deviation of 15. Find, let's go 90% this time. 90% confidence interval for the mean of all chem test takers. Whatever.
With a standard dev.
Okay. I don't know. I'm sorry. I get to zoom in. I get to cheat. Ha.
Boo.
Boo. Cancel.
90% confidence for all.
90% confidence interval. Okay. All right.
Don't know how I'm going to do this.
Huh. Pull out the variables. What is 22? N. What is 70?
Can we
That's
use
6,
this?
7.
That's the mean chem score.
No. S?
So the little U thing, the mu is.
Is the mean of the sample.
Yeah.
Nope, not mu.
Oh, is it the X?
X bar.
X bar. Average of the sample is X bar. Did I write that over here? Oh, we didn't.
You have it on
X bar equals sample average. Sure, if you need that. Sample average X bar. I forgot about him because you don't use him in your error. Okay, standard deviation of 15, so that is S. And then we need to decide whether we're using Z or T. Which one?
I've been doing so long.
No.
T if it's less than 30.
Back in the vampire days.
Yeah. So we're using T because N is less than 30. It is or less than or equal to 30. It is 22. So
We go to 20.
oh gosh. All right. So we are looking up 90% at how many degrees of freedom? 21 degrees of freedom. All right. And we're on the T chart because we have 22 students. We need to be on the T chart, and the T chart is the chi chart, but the other side. Right? I don't have him. Where is my... Oh, right here. I have somebody's. This isn't mine. Is somebody missing one?
21.
Chi chart, T chart. T chart is the three things. Okay, so go down to 21 and go to 90, and 90 is like the fourth one over, and he is 1.721. I'm going to circle him because I got a lot of stuff written there. Okay.
What is it?
1.721. Okay. Next. Now what?
Can I see that, Billy?
Plug it in.
Error equals
Equal to
1.721 times S is 15 over the square root of 22. I about put 70. All right. E is not going to be a decimal less than 1. It maybe is, but it's not like proportion. 1.721 times 15 over the square root of 22.
I got.
Should we go 2 decimal places?
4 sevens.
Ooh, that's not what I got.
1.477.
That's not what I got.
Oh.
I got 5.503.
Square root.
That one
of
makes
22.
more sense.
Oh, 504, I guess. We'll go that.
15 divided by that.
5.504. Yeah.
Oh.
Remember when we ate those peppers in the ag barn?
5.504.
That thing caught me off
Oop.
guard.
Okay. All right, these two numbers mu lives between. I take X bar, which is 70, and I add 5.504. Oh, excuse me, subtract on this side. 70 plus 5.504. I can do this one. 75.504. And this one is, I don't know, 64.496.
Yes, but you rounded up to 64.5.
Oh, sure. Yeah, so 64.5 if you want to do 1 decimal place. I'm fine with that. I don't care. 75.5. Because I think the rule is you always do 1 more decimal place than what they give you originally. Well, they gave me no decimal places to begin with, so we just do 1 more decimal place. Whatever. Okay, so 64.5, 75.5. Okay. All right, so we are...
Can we use the one below again?
Yes, the one below. Yep, this will go with him. Okay, we are how confident? 90% confident that if we do what?
Survey.
Survey, sure. Who?
All chem test.
All chem test takers.
All chem students.
Sure. All chem students. Yeah, I'm okay. I'll go with test takers. Test takers. They whatever. Chem test takers. Their what? Mean score. So it's still we're still talking about the mean score.
Is between
Will be between
64.5.
64.5 and 75.5. Okay, now that's the mean of all of them. That's not one student. Like one student may not score between a 64.5 and a 74.5. But if I take an average, they could get a 98, right? But if I take the average of all of them, it will be between those two. Okay, that's what we're saying. So again, there's my 5 things. We are how confident, all of them, mean score, and the range. Okay, got it? Those are the 4 things that we need. Beautiful. Let's do the last one, and then we'll bump back up and do ends. Okay. All right, confidence intervals. This one, if we go here, I'm going to go to the second box over, just like we started the other one. This one does not have minus and plus the error. What symbol do we use for this guy in the middle? Standard deviation.
Mu. Or the sigma.
Sigma. Circle with a hat. That's what he is. Okay, in order to find this guy, we take the square root of n minus 1
Oh,
times s squared
man.
over chi squared
R. L. R.
is it r or l?
It's R. It's R. It's R.
It's r because the r goes on the right goes on the left and the left goes on the right. Ha ha. And this one is the same. N minus 1 times s squared over chi squared left.
This is the new formula.
Yep. That's just the whole thing. We don't have an error. That's the whole formula. I should have moved him down a little bit. Anyway. You can make him take up 2 boxes.
X
Whatever.
squared R.
Okay. What chart are we on?
Try.
The chi chart.
Well, like the P.
The chi-squared chart, no matter what. Okay. We need N. We need DF. We need S. We need chi-squared right and chi-squared left. Okay. Am I going too fast?
Yeah.
Oh, okay.
Oh, you got your answer going.
Okay. We gotta get done. We got Skittle tomorrow.
What is this for? Confidence interval for what?
For standard deviation.
We could do Skittles Monday and Tuesday and Wednesday. So then we don't have to do anything. Start a new chapter.
Yeah, but tomorrow all we're gonna do is open Skittles and count. That's a Good Friday
And then
project.
eat them.
I thought there
And
was a
eat them.
test. What's this for then?
Well, we'll take the test eventually, but you're gonna want those formulas for
We
the
get
Skittle.
gummies.
Okay.
Food.
All right. What's N?
Doesn't sound very good. I think I shall have M&M's.
Number sample. Degrees of freedom is. Ooh. What's degrees of freedom?
N minus 1.
N minus 1. S is standard deviation for the sample. What's chi-squared right? Chi-squared left?
Look on chart.
Number chart. The numbers from the chart. And that is all. Oh, I went over in my box. Dang it.
Wait.
Oh well.
Do not.
Standard deviation of what?
Standard deviation.
Of what?
Or sample. I don't know. What are you asking?
What do we do?
That example.
I need an example.
Oh.
The deviation of what?
Out of town dates. Prom's coming up.
For what? But what about them, though?
Mile radius.
Deviation of
Standard deviation of IQ points.
because of ice.
Caught me off guard, Will.
Let's do the. Yeah, let's do the standard deviation of like mileage for people that drive to school.
Okay.
Is that confusing?
No.
What happened to it?
55 students
You want a sweet treat?
who drive. Who drive. Drive an average. I'm just going to say, I'm going to get rid of my who. 55 students drive an average of.
12.
You can just cross it off. Drive an average of how many miles?
12.
12 miles to school? Are you sure?
15.
I think that's less than 12 because there's a lot of in-towners.
10.
Let's go.
And then you got the
Let's go
YS.
9. 9 miles to school with
Oh, me, Logan.
standard deviation of
Who else was far?
2.5 miles.
Josie, yeah. Josie was kind of far.
Kind of far.
Find
This is Jace.
the
Oh yeah, I forgot you guys were pretty close.
find the
Like neighbors, right?
Yeah.
99% confidence interval for standard deviation of all student drivers. Okay.
You're joking.
Why? Oh, it's fine. Just move them. Just smush them around. It's fine. It's fine. It's fine. It's fine. Just leap out the other side and then it'll be fine. It's fine.
55 students.
Where's your big mistakes eraser?
I don't know. He's like, oh, right here. Ah, big mistakes. I feel like it's gonna bust in half if I throw him. Ready? Ah. You got him. Okay.
And your butler didn't knock over.
All right. All right. 55 students. What's 55? N. Drive an average of 9 miles. What's 9?
Average, that's the.
No. S.
S.
It's S.
That's the standard deviation.
Oh wait. Yeah.
But it's
What's
a-
9?
That's Sigma.
Sigma.
No.
Whatever it's called.
No.
Mu.
They drive a what?
X bar.
That's X bar. Guess what?
We don't need it.
We don't need it. But I gave you it anyway. Because sometimes you're given more things than you need. Okay. S is
2.5.
2.5. Find the 99% confidence interval. So 99% tells me that I need what my chi-squared left number and my chi-squared right number are, right? Okay. Oh, by the way, degrees of freedom. How many degrees of freedom do I have?
Oh my gosh, I wrote it.
50.
in the wrong one, too.
4. Do we have a 54 though?
That's what I did.
Oh man.
Why didn't we do
We
this?
round
Oh.
to
We're coming back.
down, which is up in the table, right? So we round to 50. Okay. 50. So 50 degrees of freedom. All right. Go to 50 and go to 99, and 99 is the very first and the very last column. And on to 50.
Now come Brendo.
You don't understand what I'm doing? Okay.
I do.
What are my chi numbers? Yep.
27.991.
Is that the right one or the left one?
That's left.
Oh gosh, 20 what?
Here's what I'll do.
27.991.
Ooh.
And then the 79.490. Yep.
Whoa. Those are big numbers.
Can I round?
No. I mean, you can on your paper. Yeah, that's fine.
What's the left one?
But I wouldn't on the test
29 point.
because I understand you're like cramped for space. So 27.991,
This is for
79.490.
90%, right?
99.
Yeah, so it's 29.707. You did 99.5%. Yeah.
What you talking about, girl? It should be the very first column.
Is 50.
The very first column and the very last column.
29.5%.
No, look at you. You don't have your things up above it. Ooh. No, you're on the right side. You're on the right side. You're on the right side. Yeah, it should be that side. But you don't have your labels. You need to have the labels up above.
I have labels.
Yeah. So here's what this means. The 90.
The apples are
Oh. You don't have your labels right. We need to fix your labels. You got wrong labels.
Oh, great.
Oh, great.
That's just what this TikTok is.
She had wrong labels too. I'm sorry.
I'll just find a Lysol wipe. No, don't do that.
Okay.
just get a
Okay.
Lysol wipe.
Okay. We'll fix him here in a minute.
Okay.
Okay. All right. Now what? He lives between.
Which
La 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 la. This is n minus 1. What's n minus 1, by the way? Oh, do we use 50 or 55?
50.
I don't know.
Wait, so what's the n minus 1?
N minus 1. So 54. Times S, which is 2.5 squared.
You guys are making-
Over 79.490. This one, 54 times, whoop, 2.5 squared over 27.991. And that is all.
Need this?
No, I just moved them down with arrows since we'll have another box.
Did you do the same thing?
Yes, I did. Just don't realize it.
So, did you put it in the one box?
So you don't have another box to the right.
Can you give this back?
Throw it.
It's so cold in here.
Stop. You're moving.
It's cold.
I wonder why it broke like
You're
with the
tripping.
G.
I don't know. Somebody chopped it in half. I think they did it on purpose. It's fine.
What'd you get?
2.06 and 3.47.
Now we write.
Now we write.
We get to use the box ball again? Hold on.
Yeah.
Are you sure?
Yep.
99%
I'm sure.
confident.
We are.
Hold on.
Look at all that writing. Man. Just a regular old drill sergeant over here.
Wait, can you go to the left a little? Oh. Can you read the numbers for the left and right? 'Cause I can't see.
27.991 is the left. And
Okay.
79.490 is the right. My handwriting is kind of hard to see.
Why are those numbers so big?
What?
Because we're being 99% sure.
And our degrees of freedom is huge. Huge.
We survey all student drivers.
Okay, we are
Standard deviation.
99% confident that if we do what?
Survey all students.
Survey all student drivers. What?
Their standard deviation is between 2.6
Their
and 3.47.
standard deviation for miles to school.
I was just gonna say for standard deviation is between this and this miles.
That's fine. Their standard deviation for miles to school is between 2.06 and 3.47. How do I know if that's like maybe even possibly right?
Because
Because
your
I was
standard
like,
deviation
they overlap.
is 2.5.
2.5 was my sample standard deviation. Does he live in between there?
They don't.
Maybe not exactly between, but he lives in between there. So I know that that's like ish the correct numbers, right? Okay. Okay. What time do we get out of here?
Couple minutes.
Couple minutes. Do we have time to do ends or no?
It's gonna bother me if we don't.
It's gonna bother you if you don't. We have time. Finding
Honestly, it
sample
looks kinda
space. Finding sample space. Yep. Yep. Yep.
It looks cool. This kind of hurts my hand.
2016, I got elected to sound in the
Okay.
Hey, Dylan, you wanna fill up basketballs next period? Because they need air.
Huh?
Won't you sit on it?
Okay. Where are you getting NyQuil? Defect. We'll see how well the NyQuil works.
Can you just open it loud?
Me?
Can you do like the
Can you whistle in and out? No, I can't do that. They're gonna be really annoyed on this video. I'm sorry. Okay, are we ready for ends?
I'm ready for a sharp.
I want to find the sample space, and in order to find the sample space, I need to find n, and the formula for n is this guy backwards. So he is, oh heavens, p hat, q hat over
Where are you at, Miss Ma'am?
z over e squared.
He had over.
I'm on the second row.
Over. What is it? Z over E.
Z over e squared.
Hang on,
Don't.
Correct. Okay, this is the same as this formula, but like mixed around for n, okay? All right, I'm not gonna write the variables down because they're right here. if you need them. Okay, same variables. All right, so I'm gonna use this is gonna be my example on formulas, whatever stuff right here. Okay, so use same example. How many
Hold on.
to survey if error is within 5%? Question mark. How many people do I have to sample in order for my error to be within 5%? So I want my error to be as low as 5%. What was my error over here? What was my error up here?
0.0934.
That is how much percent?
That is
9%. I had a 9% error above, right? But I want my error to be less. I want it to be more accurate. I want my error to be lower, which means I have to do what with n?
find.
Bigger.
N must be bigger. Bigger than what? Than what it was before. And it was 100 before, right? So I know that n has to be bigger than 100. All right, here's what we're going to do. I need to find n. And what was my p hat?
0.65.
0.65. What was the q hat?
0.35.
0.35. Okay, and we're still going to use the same information. Z was
1.96.
1.96, and I want my error to be within 5%, so what do I put for E?
5.05.
0.05. Okay, and that's squared on the bottom. What does N have to be? I'm sure. 0.65. Ooh. 0.65 times 0.35 divided by
Should be
1.96
sampling.
divided by 0.05
Actually, it's gonna be more than that.
squared.
Wait a minute.
Enter. Holy Moses. That's not right. Something is not right.
What's his middle name?
E over Z.
Yeah,
Is it the square root?
Oh, holy schmoly.
Don't. What?
I'm writing it.
Ah,
She messed it up.
I screwed up the formula.
No.
No, you didn't catch it.
And I wrote
It should be E over Z, not Z over E.
I wrote that the first time.
Sorry.
Okay.
Sorry.
really weird.
0.05. I was getting weird answers, and I'm like, that's not right. That can't be right. Blah, 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 blah. Okay, sorry. I apologize. Kinda. I'm a little sorry.
It's fine. It works.
That's much better. 349.6. Always round up. 350 people. Whoop. And we're going to run out of time.
Do not move. I gotta fix all your mistakes. Don't
Sorry.
move.
Easy.
Don't breathe.
People that do surveys, do they actually use that formula to find an exact percentage?
What do you mean?
Like, if
Yeah, when
they
they're
needed a higher population to survey, do they do this?
Mhm.
Or do they just crank it up?
well, they probably put it onto their computer and it does it for them.
Look at these tables.
But it's not really that hard of a formula. I mean, you can do it by yourself. So. We're staying here.
Oh, we're just staying here?
Yeah. Yeah.
Why? Matt has something.
Because I have on my what?
She said we can go get it.
Oh, okay.
What? Yeah. If you need to go down to the. Okay, we're gonna stop and we'll do this little bit. We'll do this little bit tomorrow, and we'll do Skittles. Okay, that was a lot of
Hang
information.
on, is there a finding sample size part 3?
No, for 7-3.
We could.
For the bottom one?
Yes, for the bottom one, we used a chart to find sample size.
Okay.
You remember it was like 95% to 99%, then you just look up how close you wanted to be on the chart. Yep. So there's not really a formula for that. It's just look up on the chart. So, okay, goodbye everybody. We'll do the last little bit and then we'll Skittles tomorrow.
Project